I got a request to talk about question 1A and 1B from the enzyme kinetics problem that we started in class that I had you finish at home, and I added a couple of questions to the list. And this one was the scenario about HIV protease. And in class, you were asked to graph the product over time, and then you then go home, calculate initial velocity, do Lineweaver-Burke, figure out Vmax and Km. But I also added two kind of conceptual questions to this problem that a student wanted me to address. So the two questions were, what exactly is the substrate? And what is the product? Okay, so we know that the enzyme is HIV protease. And for the HIV life cycle, it needs to express its genes and make a certain number of proteins to help itself replicate. So in lecture 20, we showed this figure. And by the way, also, this is from our textbook, and you can also read the section of the textbook that describes this in a little bit more detail if you'd like that detail. So with the HIV genome, when it gets made into mRNA, which is then translated into protein, the products are these large, what are called polyproteins, and poly means many, so there are many proteins, and they're not individual proteins yet. They're these large kind of conglomerates of functional proteins, but they're stuck together. They're still on one polypeptide chain, so they're not functional. What the HIV virus needs to do in order to make those proteins become active is to cut them. So proteolytic cleavage then cuts these polyproteins into these active enzymes and these envelope proteins, and those are the proteins that are going to help that virus replicate and get passed on. So this is done by HIV protease. Remember, we studied proteases in multiple contexts. Here's a new context. The cutting of a protein to create functional ones from a polyprotein. So if you were to, then going back to the question, what is the substrate of HIV protease, you would say that the substrate are these polyproteins. What is the product? Well, the products are these functional proteins. And the figure after this in lecture 20 goes into the mechanism. It's a super close-up of the active site. So look at that if you'd like to go to that next step of resolution. But this is basically all you need to know to answer the two questions from the enzyme kinetics homework problem.